Okay, we said yesterday we're going to come back to the scalar product. Okay, now there is another version of the scalar product, and that is if we're given it in component form, x1, y1, z1, x2, y2, z2, then the other version of the scalar product is x1, x2 plus y1, y2 plus z1, z2 is the scalar product as well. It's equivalent to magnitude A, magnitude B times the cos of the angle between them. Now, from that comes this following thing. If A dot B is equal to 0, then the two vectors are perpendicular. Because if we look at it, if this thing is 0, magnitude A and magnitude B can't be 0 because they wouldn't be vectors if they were 0. So that means cos theta has to be 0, and you know that means that theta has to be 90 degrees. So if we work out the dot product, normally by using this version here, and we can show that that is 0, then we can state that vectors A and B are perpendicular. So now we have a test for perpendicularity. Okay, for example, show that these two vectors here are perpendicular. Well, let's write them in component form. 3 minus 4, 7. And S is 5, 2 minus 1. So we have R dot S is equal to 3 times 5, that times that, plus minus 4 times 2, plus 7 times minus 1. So that's 15, minus 8 is 7, take away 7 is 0. That gives us 0. Okay, once we've shown that the dot product is 0, we can state, therefore, 3 dots, R and S are perpendicular. So, multiplying the x coordinates together, the y coordinates, the x components, the y components and the z components together, if you add them up and it gives you 0, you can state that those two vectors are perpendicular. Right, we can also use this for this sort of question. It says, given that these two vectors are perpendicular, find m. Well, that simply means that, look, 3 times m plus 1 times 2 plus 5 times minus 1 must come to 0 because we've been told they are perpendicular. So we have 3m plus 2 minus 5 is minus 3 equals 0. That'll just give us m equals 1. So if they've told you if two vectors are perpendicular, you know that their dot product is 0 and you can use that fact. Okay, so now we have a test for seeing whether two vectors are perpendicular and a way of finding out components if we know that two vectors are perpendicular. In the next bit, we're going to have a look at this other bit here, because if we equate these two parts when it's not 0, we can work out what the angle is. So we're going to go on to that bit next. Okay. This is the same as last time. Remember, we know that these are two equivalent versions of the dot product or scalar product. So we can rearrange this so as cos theta is equal to x1, x2 plus y1, y2 plus z1, z2 over the magnitude of A and times the magnitude of B. And that enables us to work out what the angle is between two vectors. So we're going to use that in this question here. Look, given that A is 315, B is 257 and C 442, find the angle ABC. Remember, angle is. So we need to work out two vectors first of all. Remember, we want the vectors going away from the point. So if you've got ABC, Yeah, what we want is we want BA and BC, don't we? Okay, so we need to work out not AB, we need to work out BA, and we need to work out BC. Those are the two ones we want. Remember, you think of it as BA means A. Write it in component form. That's the position vector of A. Take away the position vector of B, which is 2, 5, 7. If we work that out, we've got 1 minus 4 minus 2. That is vector BA. BC, well, we take C, 4, 4, 2. Take away B again, which is 2, 5, 7. Giving us the vector 2, minus 1, minus 5. Okay? We also need, you'll see from this thing, we're going to need the magnitudes, aren't we? So if I want the magnitude of BA, it's just, remember the square root, we did this earlier, square root of these three. So 1 squared plus minus 4 squared plus minus 2 squared. What's that? 1 and 16, 17 and 4 is 21. So that's a root of 21. And for the other one, for BC, that's going to be the root of 2 squared plus minus 1 squared plus minus 5 squared. If we work that out, what have we got? 4, 5, 30. Like that. So now we've got the components and we've got the magnitudes. So we can use this thing now. So cos theta is going to be x1, x2, so 1 times 2, plus minus 4 times minus 1, plus minus 2 times minus 5. Okay, all over that times that. Root 21 times root 30. Okay, so what have we got here? 2 plus 4 is 6, plus 10 is 16. We've got 16 over root 21 times root 30. Going to reach for my calculator now. Okay, turn it on. What have we got? We've got 16 over, and it'll nicely do roots, root 21 times root 30 equals, and it gives me, I would keep quite a lot of accuracy, so I'd keep at least 5 decimal places here. 6, 3, 7, 4, 6 to 5 decimal places. So theta is going to be the inverse cos of that, which gives me 50.4 degrees, rounding to the nearest tenth. So that would be the angle between them. Remember, if we get a negative here, it means we're dealing with a second quadrant angle. So make sure you get a second quadrant angle. You can always do it by working out the positive one, yeah, and then taking it away from 180. Okay? Because your calculator might give you minus something as an angle. You don't want minus something as an angle. You want 180, take away it to give you a second quadrant angle. Okay, so that's how we work out an angle. We should now be able to do the last exercise on this, which is working out angles and, remember, the showing that vectors are perpendicular.